Don't forget to subscribe and ring that bell.
Hey, 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 hey. Let's finish up this test. This is the last and final video, and we will cover short answer problems number 32 through 37. Let's go. We are going to start with number 32, and this is the last 2-point question. So this is part 2 short answer. This is a 2-point question, and after that, the value of the questions, the points per question will go up. Okay? So number 32 says, an app design company believes that the proportion of high school students who have purchased apps on their smartphones in the past 3 months is 0.85. A simulation of 500 samples of 150 students was run based on this proportion, and the results are shown below. That's what our nice, fine, little handy-dandy table is right here. Okay? Now they have the actual question part, which I'm going to read. Suppose a sample of 150 students from your high school showed that 88% of students had purchased apps on their smartphones in the past 3 months. Based on the simulation, again, this is the simulation. So based on this data, would the results from your high school give the app design company reason to believe that their assumption is incorrect? So is their assumption not correct? I think the logic here is more confusing than the math. What do I mean? First of all, is 88% a common thing? Okay, if we took a sample of 150 students and it showed that 88% purchase app, is that normal or not? Let's determine that first. Okay, in any time we need to find out if something is a common occurrence. All right, I need to look at the mean, which is this funny little symbol, plus or minus 2 standard deviations, SD. Really, on your calculator, standard deviation is that crazy little pigtail thing. But for some reason, this looks close enough to an M, I use it. And then I just put SD for standard deviation. That's going to give me an interval of 95% of all data is going to fall in that interval. That tells me everything that's considered normal. Let's go further. Okay, it tells me what my mean is right here. It's 0.852. I want to add and then subtract, okay, 2 different equations. I'm going to do this twice. 2 times whatever the standard deviation is. The standard deviation is listed right below the mean. So it's 0.029. So first I'm going to add 2 times the standard deviation to my mean, and I'm going to come up with a number. And then I'm going to subtract it. All right? And that, again, like I said, is going to give me an interval that contains 95% of all my results. And if it is inside that interval, that is considered common. So let me turn on my calculator, and I am going to put my mean in there. It is 0.852 plus, I'll start with the plus, 2 times my standard deviation, 0.029. And I hit enter. Okay, so 0.91 is considered the upper bound because we've added. Now I'm going to do the same thing, okay, but instead of adding, I'm going to subtract, okay, and that's 0.794. All right, so what I'm going to do here, 95% of all my data, things that are considered common, they are normal, okay, or normal, happen within this 95%. 95% is represented anything from 0.794 to 0.91 is considered normal. If I get an average that is in this interval here, it's considered normal. Okay, so let me do this one further. Now let's take a look at what this company found. 88%. Okay, well, we should know that 88% is the same as 0.88. So the question now becomes, is 0.88 in our interval here? Yes. 0.88 is in between these two numbers. I don't care if it's exactly in the middle or not. As long as it falls in between those two numbers somewhere, it's considered a common occurrence, or it's considered normal. All right? So now, what the question is asking us is, if this number that is a common occurrence is what this company came up with, okay, would the results, the 0.88, okay, that the app design company give them reason to believe their assumption is incorrect? Okay, what's their assumption here? Let's read it. Suppose for 150, your high school showed that 88% of students had purchased the apps on their smartphone in the past. Based on the simulation, would the results from your high school, the app company is incorrect. So would the app company be incorrect to say that 88% bought the app? And the answer is no. Any number, okay, in between 0.794 and 0.91 is common, which means there is a good chance it did happen. Okay, it's common or normal. 0.88 is one of those numbers that's considered common. So are they incorrect to say 0.88 happens? No, not at all. 0.88 happened. I got 0.90. That's another one that's in my interval here. Okay, 0.81. That's also in the. Those are all numbers that are 95% of all output that happen, and they're considered normal. Okay, so let's answer the question. And first of all, no, they are not incorrect. No. How come? And I'm going to say since 88% or 0.88 falls within our 95% interval. They always ask one question that deals with this 95% interval. And when I say 95% interval, I just mean it's the mean plus 2 times the standard deviation, and it's the mean minus 2 standard deviations. This interval right here that we come up with, that is 95%. Any number that's within that interval is considered an expected occurrence. It's common. There is a good chance it'll happen. Okay, we are going to step it up as we go to question 33. These questions are worth 4 points each, so they're going to be a little bit more complicated. So let's start with number 33, the first of the 4-point questions. Patricia creates a cubic polynomial function p of x. Cubic means the biggest degree, or excuse me, the degree or the biggest exponent is going to be 3. That's what cubic means, all right? And this, we're going to call this function p of x. It has a leading coefficient of 1, okay? The zeros are 2, 3, and -6. So let's write an equation for this, and then afterward, we're going to sketch it on p of x. We're going to sketch it on this grid. We're going to sketch the equation p of x. So I have done this in my class a lot. If my answers are x equals, because it says zeros. Zeros are the same things as roots, solutions, x-intercepts. So first of all, I'm going to kind of skip ahead to the sketch for a moment. If the zeros are the same thing as x-intercepts, I should have my graph touch the x-axis at 2, 3 and negative 6. So let's say negative 6 is way out here. Here's 2 on the x-axis. Here's 3. My graph has got to go through those 3 points because those are my 3 zeros. They're the same thing as x-intercepts. Okay, I'm not going to sketch it yet. But let's come up with the actual equation first. So I can say x equals 2, x would equal 3, and x would equal negative 6. Now, how did I get those? If I were going to solve this, this would come from something I call t-boning here. I create t's. Those would have to come from factors, right? If x equals 2, that would have to come from the factor x minus 2. Okay. If we have x equals 3, okay, that would have to come from x minus 3. And if x equals negative 6, that would have to come from the factor x plus 6. All right? Now, look, sometimes, kids, you can just say p of x equals x minus 2 times x minus 3 times x plus 6. And that will be okay. That's an equation. That's an equation. It's cubic because you have the 3 x's. All right? Right. So right here, this is actually good enough. I would normally FOIL that again and have it all like as a polynomial with x cubed plus something x squared. But that's fine because they don't say I have to write it in standard form. Okay? So I don't got to write it with my x cubed first, plus or minus something x squared, plus or minus. It does not say to write it in standard form, so don't stress yourself out. This is perfectly A-okay. Now, I've got to sketch this here. Okay, I've got to sketch this. It's got to go through those 3 points. So right off the bat, I'm going to put 1 point here, 1 point here, and 1 point here. If I wanted to, and you probably should, I can put this in your calculator, this part right here, put that in y1, and just take a look at how it ends. Is it going up and to the right? Is it going down and to the right? Is it going up and to the left, down to the left? You'll notice that if you graph that, on the left side, it's going to be going down. And on the right side, it's going to be going up. So I just want to make sure I go through those 3 points. So I just go down. And there you go. For a 4-point question, that was beautiful. Love it. That is full credit. No, we got a statistics problem right here. A public radio station held a fundraiser. The table below summarizes the donor category and the method of donation. Okay, to the nearest thousandths. Okay, we're probably going to be using our calculator for this one. To the nearest thousandths, that's 3 decimal places. Find the probability that a randomly selected donor was categorized as a supporter given that the donation was made online. Anytime, okay, and this is where I like to use my highlighters, I need to find out that the donor was categorized as a supporter. So I'm looking supporter, this column right here, okay? But here's the issue, the word given. Given that the donation was made online. Whenever they say given, that means I am only going to pick my supporter out of the group that made the donation online. I don't care about anything else. I am only given this group to pick from. You see my method of donations, there's phone calls and there's online. If I'm only given online, I am not going to get to pick from this here. Okay, I am given this information right here to pick from. So if I add all of my online donations, whether they're a supporter or a patron, if I add them together, 1,200 and 2016, I get 3,216. So altogether, there are 3,216 people that made a donation online. Out of this, because that's what was given to me. These are the online people. Out of all the online people, how many are considered supporters? All right, well, this column is the supporter column, isn't it? 1,200 out of the given 3,216 were supporters. And I'm just going to put that in your calculator and round 3 places. So turn it on again. And we're going to take 1,200 and divide that by 3,216. And I got 0.373. Again, they want it 3 places. The number after it is less than 5, so my 3 will stay the same. Okay, so it's 0.373. It does not say percent. It says probability, so leave it like this. Don't make it 37.3%. Probability means that decimal without a percent. All right, and the second thing is, do these data indicate that being a supporter is independent of donating online? Okay, what that means is, does it matter? Does it matter if I'm just a supporter in general? I'm going to use sup for supporter, versus what I just figured out here, a supporter given. It's only an online group. Okay, if they're the same, then yes, it is independent. If they are not the same, then it is not independent. What do I mean? Well, we need to find the probability of just being a supporter versus the probability of a supporter given being online. We just found this one out. That's 0.373. Are these equal? All right, well, let's go back up to our table. I want everyone here, not just the online people, because I need to figure out a supporter of the whole group, the probability. Okay, so if I add the top up, if I add these two, that's 1,072 people. Okay, so if I have 1,072, yep, come on, there we go. If I have 1,072 people that were phone calls and 3,216 people that were online, and I add those up, that'll give me everybody. 8, 8, 2, 4. Okay, so 4,288. Okay, we got this here. Split this up. I'm just going to kind of create these cells here, and these are my totals. Okay, but I want to do the totals on the bottom here as well. I'm going to add going down. So this is 1,600, and this is 8, 8, 6, 2, 20. Okay, so these would add up to be 4,288 as well. So I have all my totals. Okay, how many total supporters do I have? Well, my supporter column is here. I have a total of 1,600 supporters, so 1,600 out of everyone. I'm not given a group to pick out of. I just want the supporters out of everything. There are a total of 4,288 people that we recorded data on. And 1,600 of them are supporters. So let's figure out that fraction right there. 1,600 divided by 4,288. Oh, that is the same exact number. Look at that. 0.373. So I'm going to come down here, and that is 0.373. So guess what? Yes, they're the same. That means, yes, they are independent. How do I know? Well, here's the math behind it. It doesn't matter if I just pick supporters out of the whole group, or I pick supporters just out of the online group. It's the same number. So what independence means is supporters is independent of anything. It doesn't matter anything else. Whether they're within this group or not, the supporters are always going to be the 373 number. It don't depend on anybody. It is independent. Nothing affects it. Okay. Okay. You know what? The first two problems were pretty easy for 4-point problems. If you are good at algebra, this is easy too. This is one of those plug and chug type of deals. You plug in what you need to and you do the math. There's nothing to decipher, decode, ask certain definitions of certain words. Just do math, okay? Solve the system algebraically. I had mentioned earlier in a previous video, if you don't know how to do this, oh, I was going to say you can graph this on a calculator, but you have a circle. I don't think you're going to be able to graph that. You might, I mean, you can, but I don't know if you're going to be able to because you may or may not know how to graph it. So we're going to do this algebraically anyways. All right? So here's what I got. If y equals negative 2x plus 7, I'm going to substitute that into this top one. Wherever there's a y, I'm going to replace it with negative 2x plus 7. Okay? So let me rewrite that. I have x minus 2 squared plus, now in for my y, I'm going to put negative 2x plus 7. And my y was minus 3, right? So I still got to put minus 3 here. And that's squared. That equals 20. Now notice I only have x's in my equation, which is fine because now I get to solve for the x. Go back to the other equation, plug in the x, and solve for y. But I got some foiling to do here. First off, if I FOIL this out, if I take x minus 2 and multiply it times x minus 2, okay, I should get x squared minus 4x plus 4, all right? But this right here, let's combine my 7 minus my 3. So I got minus 2x. And when I combine these two, 7 minus 3 is a positive 4, so plus 4. This is what's going to be squared, okay? Now, if I take minus 2x plus 4, and I FOIL that to itself, okay, I do double distribute that and double distribute that, I get plus 4x squared minus 8x, that's minus 16x plus 16 equals 20. All right? So when I FOIL that, that's what I get. So now I just got to get to a point where I'm going to combine like terms. I'm going to combine like terms. So we have 1x squared and 4x squared. That gives me 5x squared. It's good. Minus 4x and a minus 16x gives me minus 20 x's. Okay. And then I have a plus 4 and a plus 16, which is plus 20. That still equals 20 here. Something awesome. I mean, if you can get through that work right there, something awesome is about to happen to us. I mean, it's an early Christmas gift. If I subtract 20 from both sides, I want to set this equal to 0. It looks like something that I'm going to have to factor and solve. 5x squared minus 20x. These cancel. Equals my 0. We're not going to have to do any sort of complicated factoring. That's just a GCF. Okay? Let's go up here. All right. Okay, that was nice. I did go up there. That's green. If I have 5x squared minus 20x equals 20, the GCF equals 0. The GCF that I can take out of here is 5x. 5x, okay? That ends with x minus 4. Well, I just solve it now. This is its own factor. So we're going to T-bone this right here. 5x equals 0, and x minus 4 equals 0. So my x will equal 0, and my x will equal 4. We are not done solving this. When it wants us to solve the system, we're going to need an x, and for every x, we're going to need a y. Okay, aren't there x's and y's? I see x's in this system, but I also see y's. So I needed an answer for my x and my y. But don't worry. Now that we have our x's, our y's are real easy. Visca, what do you mean? This is what I mean. You see this equation that we started with? y equals negative 2x plus 7. Well, I have two values to throw in for this x. I have x equals 0 and x equals 4. So let's just solve for each one of them. If y equals negative 2 times my x, which in this case is 0, plus 7, y would end up equaling 0 plus 7, which is 7. So when my x is 0, my y is 7. This is one of the answers. Let's do the other side. If y equals negative 2 times x, in this case, my x is 4, plus 7, negative 8 plus 7 is negative 1, which means when my x is 4, my y is negative 1. That's my other answer. Done and done. That took a little bit of time. It's a 4-point question. It's going to. All right? If you know basic algebra, you got this. Number 36, and this has a little screwball in it. Let's see who can get it. 36 reads, on a certain tropical island, there are currently 500 palm trees and 200 flamingos. Okay, right now, there's 500 palm trees. I'll do that in green. And the flamingos are, they're kind of pinkish, so I'll do it in these. 200 flamingos. Suppose that the palm tree population, okay, now we're talking about palm trees, is decreasing at an annual rate of 3% per year. And the flamingo population is growing at a continuous rate. Here is the screwball of 2% per year. Okay, that's the information they give us. The two parts that they ask us for is as follows. Part 1 here says write two functions, p of x and f of x, that represent the number of palm trees and the number of flamingos on this island, respectively, x years from now. All right, let's go. Let's go here, and green. Yeah, we like green. Let's start with p of x. I think that's the easier one to do. Okay? If we are writing equations with growth and decay, we're always starting out with our initial value. We're starting out with 500 palm trees. And then if it's growth, it's 1 plus my rate raised to my time, which is in years. Now, I'm not going to use t. They tell me I need to use an x here, and here they're saying use an x. I have to use an x to represent years. Okay? So what is my rate? First of all, it's decreasing. So I'm not going to add my rate. It's going to be 1 minus the rate because it's decreasing. My rate is 3%. So I take 1, subtract, well, 3% is like 0.03. So I can put 1 minus 0.03 in there, or I can actually subtract them and get 0.97. I can put this in there or this. It doesn't matter. I'm going to go with a 0.97. This is p of x. Now for the screwball part. My flamingos, f of x. I still start with my initial value. Okay, I initially have 200 flamingos. But if I look at my palm trees said annual rate. That's why I wrote it the way I did. And if we look at flamingos, it says continuously. Continuously, or continuous rate, means I take my initial value, multiply it times e, okay, and raise that to whatever my rate is times my time. My rate is 2%. So if my rate is 2%, that's like saying 0.02. So my exponent starts out with 0.02. And my time, again, we're going to use x for that for years. That's the screwball right there, kids. Right there. All right? So there we go. We have our two equations, p of x and f of x. Let's state the solution to the equation P of X equals F of X and round to the nearest year. Okay? Interpret the meaning of this value within the given context. It doesn't tell you to algebraically do this. So I'm going to take my P of X, which is 500, 0.97 raised to the X, and set it equal to F of X, which is 200 E raised to 0.02x. Now, what I'm going to do is I'm going to put this in Y1, and I'm going to put this in Y2, and I'm just going to see where they intersect. And that's going to be my answer. Okay? And since we're using green and purple, let's use green and purple here. I know I said Y1 and Y2, but we're going to go green and purple. Y equals. Green is down here. That's 500 times 0.97 raised to the X. And purple is right above that. It's 200 E, which is above ln in blue, raised to the 0.02x. Now, if I graph this, in the top corner, you see this thing kind of just spinning here? That yellow thing spinning? Our graph is not done until that little yellow circle goes away next to the battery. Okay, it's still working, it's still working. Still working. Still working. Guess what, guys? Still working. Still working. There it is, it's done. I see nothing. Guess what? I'm going to press the zoom button in the top middle, and then I'm going to go to a little special zoom. I'm not going to zoom in or zoom out. I guess you can keep on zooming out until you see it, but I don't press zoom fit. What that does is it backs out enough so that it fits everything that I want on my screen. Okay, so here is the increase, flamingos. Okay, and here's the decrease in palm trees. Let's hope we can see the intersection. We might have to adjust our window even more. And we do. It looks like they're going to intersect somewhere off the edge over here. So I want to go further to the right side on my x-axis. Remember, this is the x-axis. I want to go furthermore, which means I want to go higher on my x-axis. So on the top of the calculator, there's a button that says Window. I'm going to press that. You see how I only go to 10? The x maximum? Let's go to, I don't know, let's go to 30. Okay, let's triple that. So let's graph that. Again, here are flamingos. They're increasing. Okay, they're increasing. And here are the palm trees, which are decreasing. Okay, and booyah! This is the intersection point. Whatever x value that is, that's our answer. All right? So if you don't know how to do that, you hit seconds, which is the blue button, and trace, because it says calc in blue above that. And I want to calculate choice 5, the intersection. So I can press 5, or I can just scroll down to it. Now, I just moved my little spider do, this little black cross, X, close to the intersection point and hit enter 3 times. 1, 2, 3. 18.159 years. To the nearest year, that's whole number. If it's 18, okay, if my x is approximately 18.159, that will just remain 18 years. And there you go. Love when the calculator gives us that answer. All right, we are on to the final question, which is worth 6 points. We got this. Number 37, the biggie. The volume of air in an average lung during breathing can be modeled by the graph below. Okay, so if you breathe in, just follow me here for a second. If I breathe in, it goes up, the air comes up, then I exhale and the air lowers and goes out. That's what that is. That is a trig graph, my friends. Okay, so using the graph, okay, so now I'm right here. Using the graph, write an equation for n of t in the form of, so it's got to be written like this. Well, we got to find out what's A, what's B, and what's C. We have to put a number in for A, for B, and for C. All right, so let's start with the obvious. C is the middle of your sine curve. This is a sine curve. So if I look over here, right here, that's the middle. So whatever y value that is, okay, right here, that's going to be what I put in for C. So if I look at this, it looks like there's 1, 2, 3, 4, 5. They go up by 200. So this is 20. 200, 2,400. That's my magic point right here. 2,400 is that line. So my C is 2,400. So I've got N of T equals, I don't know what A is yet. The sine of, I don't know what B is yet, T, but it's going to be plus 2,400. Now, A represents the amplitude. So what is amplitude? Let me do this here. We know for a fact that we start at 2,400. Amplitude is how far up and how far down from the middle am I going. This is the high point. The high point is at 2,800, right here. The low point is at 2,000. Okay? So if I start at 2,400 and I go up to 2,800 and down to 2,000, that means that from my middle line, I'm going to go up 400, and from that middle line, I'm going down 400. 400 is the amplitude. That's my A value. 400. Okay, we're doing good. Last but not least is that B value. Okay, this B value, that's the trickiest. That is the frequency, the number of curves that I see in 260 degrees. So there's this formula. My frequency is 2 pi divided by the period. Now, these are interchangeable, the F and P. If I needed to find the period, I could say period is 2 pi divided by frequency. But they're interchangeable. And since we need to find the frequency, because that's what number goes here, that's what the B is, it's my frequency, I'm going to use this. Yep. Back one more, boom, there you go. I'm going to use that. So the distance is 5. The length of one curve is 5. So I'm going to take 2 pi and divide it by 5. And that is my B value, 2 pi divided by 5. So we've answered the first thing. Yada, yada, yada. Ooh. The second question here is as follows. Let me erase that. That same lung that's graphed in sine, when engaged in exercise, has a volume that can be modeled by E equals 2,000 sine of pi t plus 3,200, where E of t is the volume in milliliters and t is the time in seconds. They want us to graph at least one cycle of this equation E of t on that same grid. So I'm going to look at E of t just like we looked at N of t, meaning this last number is where the midline is, the middle. So I'm going to start at 3,200. So I'm going to go right here. This mark right here, which is 3,200, is the middle of my sine curve. All right? And this 2,000 is my amplitude. That means it's going to go up 2,000. Oh, my goodness. It'll go to 4,200, up to 5,200. This is going to be my max, the highest point I go. And then I got to go down 2,000 for my middle. So I'm going to go to 2,200 and to 1,200. That's going to be my low point or my minimum of my little S curve. The only question I have is, how long is this curve? And that, my friends, is where my frequency comes in. Remember, frequency and period here are switchable, okay? Which means I can say my period is 2 pi divided by whatever my frequency is. The frequency happens to be pi. Okay, so if I simplify that, the period is 2. So my graph that's going to start right here, where this blue dot is going to go out and end at the number 2 on the x-axis. Okay, at the number 1 is the midpoint. Okay, and in between those midpoints, okay, I'm going to go with my maximum way up here and my minimum way down here. All right, and I've just got to connect these dots. Okay, it says graph at least one cycle. There's one cycle. All right. How many times during the 5-second interval? Now keep in mind, 5 seconds starting at 0 going to 5. So in between these x values, or time in seconds, how many times will my new graph, E of t, this one that goes way up and way low, cross N of t? Don't say 2, because if I go out 5 seconds, I would have to draw another curve. Okay, I'm going to extend this in red. Okay, I'm going to continue this blue curve in red. I'm going to go out another 2 seconds. And in between it, 3 seconds is the middle. And they go way up high in between the first 2 dots. And in between the second 2 dots, we're going to go way down low. I'm going to connect that. So, and then if I wanted to go on again, it would kind of go up and it would stop, something like that. So how many points of intersections? Where are they the same? 1, 2, 3, 4. And if you only graph it once, you will only see 2 of those, the graph in blue. Okay, but if we continue that blue graph in red, we can see that it crosses 4 times. And that's all they're asking, is the number of times. Will these be the same when they intersect? 4 times. That is it. We are done. Enjoy.
Don't forget to subscribe and ring that bell.